Hello, and welcome to this episode of Casual Endeavors. Today I'll be demonstrating how you can create and train a simple AI using a genetic algorithm. I'm going to start the program using Spider, which will make the current working directory the folder the program is in. This allows the program to automatically find and load some important folders. Specifically, the folder's AI Save folder, where AIs can be saved and loaded from, and the Cars folder, which has images of cars that will be displayed on screen. The only things that have to be done is selecting the correct folders, and all of these have already been found for us. So I'm going to leave everything as default and go set up the AI training procedure. Here we have all the training parameters that can be set to change the training process. The training process works in the same way as the layout of these parameters, starting at the top and working its way down. There are 2 points where there are 2 side-by-side columns. The training process will use a probability to determine which of the 2 columns to progress down. The last parameter right before the 2 columns is the property that determines the probability of selecting one column over the other. I'm going to leave most of these with their default values. It should be noted that the default values used here are not selected because they have been found to perform well, but simply that they are valid and allow the training process to work. I'm going to add 2 hidden layers to my AI. The input and output layer sizes are defined by the inputs to the AI and the required control outputs, so we can ignore these. I'm going to add one hidden layer with 15 nodes and the second layer with only 10. These values are chosen for demonstrational purposes only, no reason beyond that. To apply these values, we enter 15, 10 and then click Update. Now we have a display showing the updated AI shape. I want to use only the breeding method of propagation, so I will set the ratio of individuals to create by breeding versus population stats to 1. The population stats is a different type of method, and more information can be found on the introduction page of this program. I'm going to leave the rest of these parameters to their default values. To begin training, all we have to do is scroll down to the bottom and click Save Settings and begin training. Unfortunately, the window doesn't auto-resize given the size of the track, so we'll have to resize it manually. All of the settings are passed to the training environment, and it immediately begins training the first generation. There is a collection of information shown on screen to give you updates on how training is going. There is the generation number, the total number of drivers left that will be shown on screen, the current number of drivers on screen, the total number of individuals from this generation that have completed their run, the number of training threads left to run. This only pertains to the training occurring with multithreading. This is not the total number of training threads running. Only a small number run at a time, and as they complete, another will start up. An indicator to tell you when there is multi-threaded training actively running in the background. An indicator for the current training mode. Note that it changes to show when the user has indicated a change of training mode, which will occur at the end of this generation's training. Finally, the current performance indicators for the previous generation. The first value is the best score obtained by an individual. The second score is the mean score for the generation as a whole, and the final score is the worst performing individual. There is also a chart at the bottom of the window which shows some training performance metrics for previous generations. The red is the high score, black is the mean score for the population, and the blue is the worst individual score. This helps to show how generations are performing versus previous generations. The green bar indicates how the scores were spread out for the previous generation. The vertical purple line shows where the mean score for the population was. This shows how individuals are performing compared to others within a single generation. Note that both of these plots are done using logarithmic data. The default training mode is 1. This will display a small number of cars on screen, but most of them will be trained in the background using multi-threading. This helps to speed up the training process. Please do not close the program while there is training threads running in the background. Training in background shows true when training in the background is actively running. You can click pause after this generation to have the game complete training for this generation, save the best individuals, and then stop. An indicator will be shown to indicate that this has been selected. Then you can safely close the program once training has completed. You can also switch training mode to 0. This will have all cars shown on screen, at which point there will be no multi-threading going on in the background, and you can exit at any time. Using a model with hidden layers can deliver better results over the course of training, but it also tends to produce much worse individuals at the start and slow down training. I would recommend starting out with no hidden layers for your first AI, and once you get a better understanding of how the training parameters work, consider adding hidden layers then. If you're interested in designing your own track, you should check out my previous video. In the AI training program, there is an option to load any track that you have.